Okay, so welcome to part 4, section 4 of the Algebra 1 MCAP practice test. And so, there's 3 types of questions on this test. There's the easy ones, the problems with, no word problems. And then there's the ones that are veiled, like they would be easy, but they ask the question in a confounded way, make it more difficult. And then there's the word problems that you really have to think through. So just keep that in mind. Just thought I'd say that. All right, the functions f and g are defined as, I think this is a category 2. It would be easy, but they kind of worded it weird. So we see we have 2 functions. That's a system of equations, right? And the point BC is on both. So that means it's where they intersect. And so we want to solve the system of equations. So how do you solve that? And then they want the inequality and all that. But we want to solve the system, so we set them equal to each other, just like we would do with 2 lines in slope-intercept form. But we see we do have a problem. So, we do have we have a problem. We have a x squared. So this is actually going to be a solution to a quadratic. So let's get everything on one side and 0 on the other side, because that's how we solve a quadratic. Now I'm going to get everything on the right side, so I have a positive x squared. So x squared and then plus x minus 1 minus 2. And squared. So x squared plus x and then minus 3. All right. So thinking about 3 and 1, and those do not add to 1. So I guess we'll use the quadratic formula. X equals, so b is 1, a is 1, c is -3. X equals -1 plus or minus the square root of 1 squared minus 4 times 1 times -3 all over 2 times 1. Going to do this inside there. So it's 1 minus 4 times 1 is 4 times -3 is -12, and then the 2 negatives make it positive 12. It's 13, square root of 13. This is the square root of 13. Square root of 13 is 3.6. Of course, it's irrational. So -1 plus or minus 3.6 over 2. So -1 plus 3.6 over 2, and -1 minus 3.6 over 2. So -1 plus 3.6 divided by 2 is 1.3. And -1 minus 2.6 divided by 2 is -2.3. That's the solutions. So those are our x values of the solution. So that would be b, So what, it must be true. Select one answer. B must, so B, there's a positive value and a negative value. So B does not have to be greater than 0. It doesn't have to be less than 0. So what about C? Now let's substitute our C, and we can choose either equation to substitute it into. I'm going to choose the linear one. So let's substitute 1.3 plus 2 and -2.3 plus 2. So -1.3 plus 2 is 0.7. And then this would, 2 negatives become a positive 4.3. So I see that in both cases, our y value is positive. So the answer, C, has to be greater than 0. All right, let's move on. Let's celebrate there for a second. All right, the librarian at a local school collected data on the number of students using the library after school each week during the first 22 weeks of school. The librarian counted the number of students in the library each day. All right, that's the slope. And then calculated the total for each week. Okay, so that's, I see now, the week number is our X quantity. The weekly totals were plotted in a graph, and then a trend line was fit to the data. So number of students is our quantity on the y-axis. For which week does the trend line underpredict the number of students using the library by the greatest amount? So underpredict, that means which point is the highest above the trend line. I think we all see that at this point right here, which is about, looks like about week 3, right? At week 3, our trend line was way below the actual data point. So it's A, week 3, way below, all right? An object is dropped off a roof of a building. The function h of x equals negative 16x squared plus 64 models the height h of x in feet of the object above the ground x seconds after it is dropped. Quadratic function, all the way. Which is the best description of the meaning h of 2 equals 0? So 2 is seconds, 0 feet. That means that thing hit the ground at 2 seconds. Oh, there we are. C. Okay, moving on. So that, how did I know that? Because x is seconds, right? And h is feet. And so 0 feet, that's on the ground. X 2 seconds. All right. The student claims that if an equation has no exponents greater than 1, then the equation is linear. Which equation can be used to show that the student's claim is false? That would have to be this guy. There's no exponent greater than 1, but we know from Algebra 1 class that the shape of the absolute value, even though it's technically called linear absolute value, it's not a straight line. It's actually shaped like a V or a if it was upside down, but it's not linear. A nursing student works at a doctor's office for $15 per hour, slope, and tutors students for $25 per hour, slope. So when I see two slopes, I'm thinking standard form, okay? So I'm thinking doctor's office is X, tutoring students is Y. So 15X plus 25Y gives us the total amount of moolah, money the students making. Oh, and look, they want to earn at least 375. So they want to make this greater than or equal to 375. Total money. And they can't work more than 20 hours in a week. So let's define our variables. Hey, look, that's the first thing we got to do. X is going to be hours at doctor's office. And Y is going to be hours tutoring. And so we multiply the money made at the doctor's office times the hours at the doctor's office. Add to that the money made per hour at tutoring times the hours tutoring. And that is got to be greater than or equal to 375. But we can't work more than 20 hours. So the hours themselves, if we add them together, has to be less than or equal to 20. So now I have done that part. Suppose the student wants to work at the doctor's office for as many hours as possible for the experience, and suppose the student can only work a whole number of hours at the doctor's office. How many hours should the student work at the doctor's office each week? Show your work or explain how you found the answer. Okay, so this is all right. It'd be so complicated. But yeah, so the student wants to work at the doctor's office. But as we can see, they don't make a lot of money there, but they want to get the experience. So they want to tutor as much as they have to. But okay, so what does that mean? What does that mean? That means that, you know, what I think would be the easiest thing to do is to, you know, even though there's some different ways we could do it, there's only 20 hours. So let's just plug in some numbers and make sense of the problem. So if we work 10 and 10, if we did that, if X, oh, let's make a table. And we'll make an educated table. So X was 10 and Y was 10. Would that work? Or let's say like this. If X was, yeah, would that be greater than 375? Because that's what we want. So that would mean that we would have, so let's look for the cost, and we want to see if it's greater than 375. And so that would be 10 and then 25 times 10. So that's 150, 250, which is 150 and 250 is 400. So that works. All right, so we already know that he can work 10 hours at the doctor's office, but can he work 11? Or she, I don't know. 11, that would mean only 9. So then we substitute 15 times 11 plus 25 times 9. So I'm just going to use my calculator. 15 times 11 plus 25 times 9, 390. So that still works. All right, so now let's see, can we work 12 hours? So let's just 15 times 12 plus 25 times 8, 380. Can't go lower than that. So the answer is 12 hours at doc office. See table. So remember, I think we said get. We said that there's 3 representations of functions, and they spell the word get. Graphs, equations, tables, and they're all equally valid, just that sometimes one is more efficient and effective than another. But hey, making a table is not bad. It may feel like guess and check, and I was guessing and checking, but the reason was because there's only 20 hours, so it was efficient. If there was 1,000 hours, then I would have had to graph it and do some more sophisticated techniques. But as you can see, I'm done well within the time of testing. All right. The quadratic function f is graphed in the xy plane. Yes, it is. For the function will be transformed to form a second function g, for which transformation of f will the equation f of x equal g of x have 2 solutions. All right, so what are we doing to transform it? I see some different options. So if we reflect it, these two are reflections across the x-axis reflecting across the y-axis. Let's write this down. This is reflect across y-axis, and this one is a reflection across x-axis. So both of those, if we flipped it, or flipping it the other way doesn't even change it, oh well, it would change it, but in any case we would still have two x-intercepts. So is there only one answer? Pause, I'll be right back. All right, so I've got it. So if we reflected like this across the, this is not a perfect reflection, across the x-axis, which is this one right here, then you can see they still they intersect. The zeros are the same. And so there are two solutions to the equation where we set them equal to each other. They intersect twice. So that is the answer. But I want to show you that this one, where we reflect over the y-axis, that is going to make a graph like this. And they only intersect once. And this one, where we're shifting in a direction, so we take this and we shift it in any direction, then it's only going to intersect once, so that's this one. And then if we shift it up, which is D, then they do intersect twice, but not at the x-axis, which is the solutions, right? The solutions are the x-intercepts, the solutions to an equation. And that's what they're asking about. So the answer is B. All right, two more guys. What are the solutions to a quadratic equation? All right, well, we've done the quadratic formula 2 times. So does this thing factor? I mean, I see integer coefficients, 32. So what is that? 8 and 4. What happens when you divide 32 by 2? 16. 16 and 2. 32 is equal to 16 times 2. And so how about 16 minus 2? That's 14, right? So x plus 16, x minus 2 equals 0. That's how that factors. That standard form goes to that factor form. And our solutions would be negative 16 and 2. Done. Factor it. You do the quadratic formula too. Right, I'm done. I factored. Person deposited, probably exponential, right? So let's see. Made no other withdrawals or deposit. Each year, the interest was added to the account. The table shows the balance f of x in dollars x years after the person deposited the money. Okay. So what we're going to do to find the best function is we're going to do our exponential and linear check. So we're going to find the common ratio and the common difference. So let's find the common difference and the common ratio, and we'll see which one. So if I subtract 10, 1, 3, 0, sorry, 130, if I subtract these two, then if I subtract these two, 10, 261.69 minus 10, 130, 131.69. So pretty close to 130. So I'm going to say linear. All right, so I'm not even going to find the common ratio because that That's really, I see the 130 and it's close to 130, and we're adding. So let's check, make sure that's right. D. Oh no, it was D. So look at that. Each year the interest was added to the account. So I guess we have to assume if we're adding interest to the account that it's exponential. Okay. So I guess it's not simple interest. I guess it's compound interest. Someone better tell the MCAP people that they didn't say compound interest. Simple interest is a linear function, but I digress. Let's go ahead and find the common ratio to make the answer key happy. So 10,130 divided by 10,000 is 101.013. And so that is our common ratio. That goes right there. Our y-intercept goes right there. So fine, it's D. But only because the answer key said so, not because I think it has to be. Because I think it could be a linear function too. Anyway, that is the whole Algebra 1 MCAP practice test. So if you don't feel confident, then you can watch it again. You can ask your questions and keep preparing. You're gonna do great.